Hello, we're going to take a look at a problem from the pyramid and cone handout we were working on in class today, the volume of pyramids and cones. And we're going to look at problem number 6, sort of down towards the bottom. Many people were having questions on number 6, so I think it's worth spending some time on. So looking at two things at this problem. First of all, we have two different shapes making this composite figure. We've got a box down at the bottom, a rectangular prism, and we have a pyramid up on the top. So there are two different figures we're finding the volume for. Let's do the easy one first, which would be the box down at the bottom, the prism. And volume formula for a prism is the area of the base. In this case, it's a rectangle or a square, so it'll be length times the width. And then you take the area of the base, the length times the width, and multiply it times the height of the prism. And in this case, it looks like it's a cube since it's a 12 by 12 by 12 box. So really, we're just going to be multiplying 12 times itself 3 times, or cubing 12. So 12 times 12 times 12 is 1,728. So I'll record that answer over here on the left side of the paper, and we'll come back to that as we work through the problem. We'll find the area of the pyramid on top next, and then we're going to add that to the 1,728 to finish up the problem at the end. So let's take a look at the pyramid. Volume formula for a pyramid is once again the area of the base, and in this case it's length times width. So we always figure out what shape the base is of our solid figure. Figure out the area of the base. In this case it's length times width because it's a rectangle, or side squared if you want to think of it as a square. And then multiply that area of the base times the height of the pyramid. So length times width times height. And then the last thing that we'll do is to divide whatever number we get by 3, or multiply it by 1/3. So that's the formula we're going to be using next. Length times width times height divided by 3. Well, the length times the width, once again, is pretty easy. I'm just going to use the 12 and the 12 from the box, from the prism on the bottom. So that's pretty easy, 12 times 12. But the height of the pyramid is not given to me. The only thing that I'm given in this problem for the pyramid is 10, which is an edge. So somehow I'm going to have to figure out the height. And let me put a different color here so it's a little easier to see. So the height of the pyramid is kind of like the tent pole, a pole that would drop down from the very top of the tent straight down to the base. I'm going to use Pythagorean theorem. I'm going to use right triangles to find that value, and I'm going to use Pythagorean 2 times. It's not too easy to see on this diagram, so either send me an email or post on Facebook and I'll put some links up that will show how to see this figure just a little bit easier. I am sketching in a right triangle inside the top of my pyramid, and the red on the side here that I'm now covering in green is the slant height, and that's the first value that I'm going to find. Eventually I'm going to be able to use the slant height to find the pole in the middle. So let me get rid of the pole in the middle here. So I'm just looking at the slant height, and then I'm going to color in the value that I do know, which is the edge, which is 10. And I actually know this little piece here on that right triangle. It's half of 12. It's 6. So I'm going to find the area of this triangle here along the face of my pyramid. Let me redraw that right triangle. Whoops, here. So this green triangle is this green triangle down below. I know that 6 is that bottom leg. The edge is the hypotenuse, that's 10. And I want to find the slant height, x. That's the part that I'm looking for right now. So I'm going to use Pythagorean theorem to do that. 10 squared equals x squared plus 6 squared. 10 squared is 100. 6 squared is 36. I'm going to need to subtract 36 from the 100. I'll get 64. I'll take the square root of 64, and I'm going to find out that the slant height, that x, is 8. So once again, I've used Pythagorean theorem here to figure out the slant height. I'm going to erase this triangle. If you want to see it again, you can rewind the video. Scroll back a little bit. I am going to leave the slant height up here, though. I'll leave it in green. And I know that that value is 8 feet. 8 feet. Remember that what I want to find is the height, which is the pole that's dropped down from the top of the tent right down to the middle. And here's another value here. So now I'm going to be looking at this red triangle, which is kind of like a slice out of the middle of the pyramid. Let me redraw that red triangle down below. So this is this triangle here, where the hypotenuse is now the slant height that we found in the last step. That is right on the side of the pyramid. That one is 8 feet. I know this part here of the right triangle, that's halfway into the middle of my pyramid. Half of 12 again is going to be 6. 6 feet. And I'll use Pythagorean theorem one more time. 8 squared equals 6 squared plus h squared. Now we're looking for that height of the pyramid. 64 equals 36 plus h squared. Subtract 36 from 64, I'll get 28 equals h squared, and h is going to be the square root of 28. So my height is the square root of 28. Let's put that right into the formula. So my height is the square root of 28. That's the last piece of information I needed for my formula for the pyramid. I'm going to multiply 12 times the square root of 28 and then divide it by 3. So let's see, let's start with the square root of 28. That seems to work better in the calculator that I'm using to help it figure out order of operation here. So the square root of 28, 5.29 something something, times 12, right? Yep. Times another 12. 761.9763 blah 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 divided by 3 is 253.992125. So this here is 253.99212 something something. Let's sort of check in to see where we're supposed to be rounding to here. We're rounding our answers to the nearest tenth. So recording that many decimal places will definitely get us accuracy to the nearest tenth. What I'm going to be doing with that value, however, let me zoom out so we can see our whole problem a little bit better. What I'm going to be doing with this value is adding it to the box. Remember that box? So here was B. So this is part B. And now in part C, we're going to add the 1,728, this value here, to the 253.99 blah blah blah. this value here. So we're taking the box, 1,728, and that pyramid up on the top, 253.99212. So let's just go ahead and add that in. Plus 1,728 is about 1,981.9921. We're rounding to the nearest tenth, which means it's going to round up to 1,982 feet cubed. And I would rewind this and look at the different parts again. Post any questions that you'd like on Facebook. Happy to do another video or answer specific questions, or send me an email at our school email address. Thanks. See you tomorrow.